Today, we're going to solve a specific type of quadratic equation. We'll explore how expanding a squared binomial can help us find the solution. Here's our equation. X squared minus the quantity x minus 1 squared equals 0. Notice that this equation contains a binomial expression raised to a power. To solve this equation efficiently, we need to first expand the squared binomial term rather than trying to factor immediately. Let's focus on this squared binomial term, x minus 1 squared. This is the expression that we need to expand to simplify our equation. A squared binomial follows the pattern of a minus b squared, which expands to a squared minus 2ab plus b squared. In our case, a is x and b is negative 1, so we'll get x squared minus 2 times x times negative 1 plus 1 squared. By expanding this squared binomial, we'll transform our original equation into a standard form that will be easier to solve. This is a common technique when dealing with quadratic equations that contain squared binomials. Once we expand the expression, we'll be able to simplify and solve for the values of x that make this equation true. This will show us how algebraic manipulation can reveal solutions that aren't obvious in the original form. Looking at our equation x squared minus the quantity x minus 1 squared equals 0, we need to expand the squared term to proceed with solving it. To expand the squared term, we'll use the binomial square formula, which is a powerful pattern in algebra. This formula tells us that whenever we have a quantity a minus b squared, it equals a squared minus 2ab plus b squared. This is a pattern worth memorizing as it appears frequently in algebra. For our specific expression x minus 1 squared, we can identify that a equals x and b equals 1 in the formula. Let's substitute these values into our formula and expand the expression step by step. The first term in our expansion is a squared. Since a is x, this becomes x squared. The second term in our formula is negative 2ab. When we substitute a equals x and b equals 1, we get negative 2 times x times 1, which simplifies to negative 2x. The final term in our formula is b squared. Since b is 1, this gives us 1 squared, which equals 1. Remember that any number raised to the power of 2 is that number multiplied by itself. So by applying the binomial square formula, we've expanded x minus 1 squared to be x squared minus 2x plus 1. This type of expansion is essential for solving many algebraic equations. With this expansion, we're now ready to substitute it back into our original equation to continue solving for x. Let's examine this quadratic equation. X squared minus the quantity x minus 1 squared equals 0. We'll need to expand and simplify this to find its solutions. To solve this equation, we first need to expand the expression x minus 1 squared. This will convert our equation into standard form, making it easier to solve. Remember that when we square a binomial like x minus 1, we apply the formula, the first term squared minus twice the product of the terms plus the second term squared. So x minus 1 squared equals x squared minus 2x plus 1. This expansion is a direct application of the binomial square formula. A minus b squared equals a squared minus 2ab plus b squared. In our case, a is x and b is 1. Now comes the crucial part. We need to substitute this expanded form back into our original equation and distribute the negative sign correctly to all terms inside the parentheses. When we distribute a negative sign through parentheses, it's like multiplying each term by negative 1, which flips the sign of every term inside. This is a common source of errors in algebra, so we'll work through it carefully. Let's apply the distributive property to each term. When multiplying by negative 1, positive terms become negative, and negative terms become positive, essentially reversing the sign of each term. For the first term, x squared becomes negative x squared because positive times negative equals negative. For the second term, negative 2x becomes positive 2x because negative times negative equals positive. This sign reversal is crucial to get the correct answer. And for the third term, positive 1 becomes negative 1 because positive times negative equals negative. After simplifying, our equation becomes x squared minus x squared plus 2x minus 1 equals 0. Notice how the negative sign distributed to create these sign changes throughout the expression. This form of the equation is much easier to work with. In fact, we can see that the two x squared terms will cancel out, leaving us with a simpler linear equation. 2x minus 1 equals 0. This demonstrates how properly expanding and distributing terms can simplify what initially appeared to be a quadratic equation. We're now working with the linear equation 2x minus 1 equals 0, which we derived from our original quadratic equation by simplifying it in the previous steps. Let's solve this linear equation to find the value of x. To solve for x, we need to isolate it. Our first step is to add 1 to both sides of the equation. This will eliminate the constant term from the left side. When we add 1 to both sides, we're maintaining equation balance. Whatever we do to one side, we must do to the other. This is a fundamental principle in equation solving. Simplifying the left side, negative 1 plus 1 equals 0, leaving us with just 2x. On the right side, 0 plus 1 equals 1. So our equation becomes 2x equals 1. Now that we have 2x equals 1, we need to isolate the variable x. To do this, we'll divide both sides of the equation by 2, which is the coefficient of x. Dividing both sides by 2 maintains equation balance. On the left side, we have 2x divided by 2, and on the right side, we have 1 divided by 2. On the left side, 2x divided by 2 simplifies to just x, since 2 divided by 2 equals 1. On the right side, 1 divided by 2 gives us 1/2. So the solution to our linear equation is x equals 1/2. This means that x equals 1/2 is also the solution to our original quadratic equation, x squared minus quantity x minus 1 squared equals 0. You can verify this solution by substituting x equals 1/2 back into the original quadratic equation. When you do the calculations, you'll find that it indeed makes both sides equal. Let's verify that x equals 1/2 is a solution to our quadratic equation, x squared minus the quantity x minus 1 squared equals 0. To verify our solution, we'll substitute x equals 1/2 into both sides of the equation. This will show whether 1/2 actually makes the equation true. Let's calculate each part step by step. For the first term, we square 1/2. 1/2 squared equals 1/4, because 1/2 times 1/2 is 1/4. Now we need to calculate the second term. Inside the parentheses, we have 1/2 minus 1. That gives us negative 1/2, so we need to square negative 1/2. When we square negative 1/2, we get 1/4. Remember that when we square a negative number, the result is always positive. So negative 1/2 squared equals positive 1/4. Now we can finish our calculation. We have 1/4 minus 1/4, which equals 0. Since our equation simplifies to 0 equals 0, which is true, we've confirmed that x equals 1/2 is indeed a solution. When a substitution leads to a true statement like 0 equals 0, it confirms that our proposed solution is correct. Now let's understand why 1/2 works as a solution by examining the structure of our equation. First, let's expand the original equation. The term x minus 1 squared can be expanded using the formula for a perfect square. A minus b squared equals a squared minus 2ab plus b squared. So x minus 1 squared equals x squared minus 2x plus 1. Now we can distribute the negative sign to each term inside the parentheses. This gives us x squared minus x squared plus 2x minus 1 equals 0. Notice what's happening with the x squared terms. The x squared terms cancel each other out, leaving us with just 2x minus 1 equals 0. What looked like a quadratic equation has simplified to a linear equation because the squared terms eliminated each other. Solving this linear equation is straightforward. We add 1 to both sides and then divide by 2, giving us x equals 1/2. This is why 1/2 is the only solution to our original equation. This example illustrates an important concept in algebra. Sometimes what appears to be a quadratic equation with potentially two solutions can simplify to a linear equation with just one solution. This happens when the highest degree terms cancel out. We've proven that x equals 1/2 is the solution to our equation by both direct substitution and by analyzing how the equation simplifies. When the squared terms cancel out, we're left with a straightforward linear equation.